Please just press again. I think it says like BPM, which means beats per minute, equals 60 times F, where F is the pulse frequency. Now, Joseph will be taking over from here.
Thank you, Amro. So now let us look at the components that we will be using for our project. The first is the Arduino development board, and we'll be using Arduino Uno. We would write the code, compile and upload it, and this would be used to control our pulse sensor and the LCD module. The second component is the pulse sensor. Pulse sensor is based on the principle of photoplethysmography, which was already explained by Amro. The third is the buzzer, but the buzzer we would be using would be a piezo buzzer. It consists of piezo crystals which change their shape when voltage is passed through them, and this change in shape will cause the plate, the ceramic plate, to vibrate, and thus sound would be produced. We would be using this buzzer so that whenever the heart rate drops below 60 or above 100, that is whenever there is bradycardia or tachycardia, the person would know that he's having a condition and would require immediate help so that any future abnormalities can be prevented. Then the next would be a 2x16 LCD module, which would be used to display the heartbeat rate, and breadboard and jumper wires would be used for connection. The total cost of a project would be approximately 1,500 rupees. So this is the Arduino Uno that we will be using, LCD module, and this is the pulse sensor.
Your last slide, second last slide before this one.
This
Yes.
one.
Yes. So your approximate cost is 15. Okay. Okay. Yes. So this is, so Arduino, I think already you said?
Yes, ma'am.
Okay. So you need basically LCD module and
we would need LCD module, then pulse sensor. Like the front part of the pulse sensor, here the fingertip would be placed for detecting the heart rate. So, and a buzzer. Buzzer is for alarm. Breadboard, jumper wires, and jumper wires will be requiring male to male. That's the only requirement. And now the circuit diagram. Here, this is an Arduino Uno. This is a pulse sensor. The positive terminal would be connected to the 5 volt or 3 volt VCC. The negative would be connected to ground, and the output, that is the signal output, would be connected to the analog input of Arduino. And the second is LCD. In LCD, the VCC and ground would be connected to 5 volt and ground respectively. And the RS pin, which is the register selecting pin, would be connected to pin number 9 of digital pins. And enable pin would be connected to pin number 8. D4, D5, D6, and D7 would be connected to 7, 6, 5, and 4 respectively. And the third is the buzzer, where the negative would be connected to ground and the positive would be connected to the 9th pin of the digital pins. So yes, and these are the references that we used for like reading about the project and coming to a conclusion what we actually want to do.
Okay, so what will be the success rate of your project? So like this 6 months time period is like 1 semester time period is sufficient, or you need some more?
Yes, ma'am. We would be able to finish it by 1 semester.
Yes. Okay, that is the point, like that is for everyone, because if we are asking for money from the university, so basically we have to give them output. Okay, so what will be the success rate, Jyotsana?
The success rate would be above 95% only, because I am already familiar with Arduino, so there won't be a problem, and so Asli and Amro also have knowledge about it, so we would be able to do it well, so 95% and above.
Okay, so Jyotsana, without waiting for this money, so I will give you that 1,500 right now, so you can start ordering your instruments. So maybe this university is going to give us money, or maybe that is not going to give us. So, but 15,000 I can pay from my website. Okay, so that is like for your project you can start. Okay, so for
Okay.
next time what you can do, so all these components should be with you, and try to purchase from the local shops, because online if you are going to purchase from the Amazon or other things, so the cost will be double.
Yes, ma'am, that's true.
Okay,
So yes,
because
ma'am, we know a place like we can go. We buy electrical components from that place only.
yes, so try to buy from there. And what other facilities you need from the university? If you want to visit, so I can take permission. So if you want to
Yes,
use
ma'am, we would like to visit one day. Like one day
no,
we
you
would
can
visit.
come. Okay, you can come weekly. Okay, there is no problem in that one. So if this class is there, so आज का जो class है, every Tuesday you can visit, और every Friday कोई भी दिन आप ऐसा कर लीजिए कि आप visit करें, and better आप यहीं पर काम कर लेंगे.
Yes, ma'am. Okay,
Okay, so I will take permission for that one.
sure.
Okay, okay then. Thank you.
Thank you.
So, okay, then I have one question for Amro then. Amro, you said like there are two ways. One is reflection, one is transmission. So which one you are going to use? Anyone can answer from your group. Suhasini? Okay. Jyotsana, which one is good? Transmission or reflection? And which one?
Ma'am,
Sorry, ma'am.
Yes. So transmission or reflection from the your like heart, which one you are going to use for this plethysmography?
ma'am, we would be using the reflective one.
Okay, what will be the advantage then?
Ma'am, the advantage would be that it would be more accurate than the transmittive one.
Okay, reason?
It would give better results.
Okay, reason?
Ma'am, basically what would happen, this is based on the volume, right? So the amount of blood that would be there, that much amount of light would be reflected.
Okay.
So, yes, ma'am.
Okay. So basically you are going to use incubation center for this one?
Ma'am, we would be able to perform this anywhere, not necessary that we need an incubation center. Any classroom would be fine for us because we just need a laptop and the components, that's all.
Okay, so you can go to VMA lab only. So we have that lab, so you can go to there. Okay.
Yes, ma'am.
Okay, so thank you. And now second job you have to do. One is this components you have to purchase, and second thing. Okay, so try to write one small paper on this one. Okay, so just for the next class, what you have to do, last 10 years study on this one. Okay, so literature review basically you have to do for the last 10 years.
Okay.
Okay, so papers will be there. So you have to find out in which journal they are going to publish those one, and what are the advantages and what are the limitations. So basically one thing you can do, start writing by the literature review, or you can prepare a table with the reference. So now you are in 4th year. So सबको Mendeley use करना आता है आप लोगों को?
Ma'am, can you
Referencing
repeat?
article. Mendeley या EndNote कोई भी एक सॉफ्टवेयर for referencing purpose. So if you are going to read 10 years paper, so 10 years में आपके 20 papers तो होंगे ही कम से कम. मैं एक बस ऐसे एग्जांपल दे रही हूँ. So those 20 papers अगर आप एक जर्नल में भेजते हो, then दूसरे जर्नल में भेजते हो, again format is going to change for the reference. Already आप लोग पेपर सबमिट कर चुके हो, देख चुके हो. So better है कि आप लोग दो सॉफ्टवेयर होते हैं. One is Mendeley, MENDLEY, that is free of cost, and one is EndNote. दोनों सेम है. एनीवन यू कैन यूज. ओके, सो मेनली इज फ्री ऑफ कॉस्ट, तो बेटर है कि मेनली यूज करें. सो कैसे यूज करना है दैट आई विल टेल यू, बट फर्स्ट आप लोग सारे पेपर डाउनलोड करेंगे 10 इयर्स के लिए. सो नेक्स्ट क्लास में सबका कंबाइन लूंगी, जिसमें मैं आप लोगों को देन मेनले के लिए इन्फॉर्मेशन दूंगी कि कैसे आप लोगों को रेफरेंसिंग पार्ट करना है मेनले के थ्रू. ओके,
Okay. For
So
next
you-
class, we have to go through all the papers, right?
papers, yes. So literature part should be completed for the next class.
Okay.
Okay, so I am just asking for the 10 years, not more than the 10 years right now. So we will slowly move to the 20 years advancement. Okay. So now you are going to do from 11 to 21. What are the advancement in this plethysmography? What were the limitation? What is new in your case? So which circuit diagram they were following, which one is which one you are going to follow, and what are the advantages? Okay. So आप कुछ
Okay, ma'am.
बनाने जा रहे हैं तो उसको कैसे आपको मतलब मार्केट में लेके आना है वो तो आप देखेंगे ना. So अभी this is the kind of practice like when you are going, maybe someone can choose their career as a biomedical salesman. Okay, so sales में भी कोई जा सकता है. So now the same, this is manufacturing part you are doing. Now the sale वाला part भी आप लोगों को सीखना है. Okay. I know maybe आप लोग नहीं जाएंगे, higher study में ही जाएंगे, but definitely these kind of activities will help you. So वो आप एक करेंगे कैसे, आपके वाले में क्या advantage है, ठीक है? Clear?
Okay, ma'am.
Yes,
तो
ma'am.
ट्राई करना कि छोटा पेपर लिख लो, छोटा सा भी एडवांटेज ही रहेगा आपके लिए, ठीक है? और बाकी आप तीनों अभी आफ्टर योर दिस वन बीटेक व्हाट यू वांट टू डू, गेट और नेट और एमबीए, आमरो?
Ma'am, my screen is visible.
Yes, Manuka.
Aishi will start, ma'am.
Good afternoon, ma'am. Good afternoon, everyone. So our project idea, we're going to present our project idea. So it is a automatic wheelchair. Next slide, Monica. Okay, so wheelchairs are very common. Like we see wheelchairs very often at airports and everywhere. But the wheelchair, what we are planning is it is going to have the following features, like we are planning to make. It is going to have the following features. It will be having a joystick mode, which will be the standard mode. Many of the wheelchairs have it in the market. Many of them have it. Further, we're going to have these hand gesture control and head gesture control in our wheelchair. It will be having the GPS monitoring system, and it will also be IoT enabled. And yes, we are going to take care of certain, we're going to include certain safety measures. Like one of them is the obstacle detection sensor. So the uniqueness about the wheelchair is we have wheelchairs in the market which will have either of these modes. So, like there isn't a wheelchair which will be having the like all the modes like joystick, hand gesture, and head gesture mode together. Furthermore, we're going to use like we will be trying to reduce the cost as like these customized wheelchairs are very costly. It's not within everyone's limit. So this is the aim of the project. Manuka, next. Okay, so here we have the list of the hardware and the software which we are going to use. So under the hardware category, we'll be having the microcontroller, the gesture sensors, the safety sensors, whatever we'll be using, connectivity, power, and movement. So under microcontroller, we're going to use the Arduino Mega. And then for the gesture sensors, we'll be using the accelerometer and the gyroscope. Accelerometer mainly for the speed, and gyroscope, it is going to maintain the orientation of the wheelchair so that it doesn't topple down. And next, we'll be using the flex sensors. The flex sensors, we're going to use it for the hand gesture mode. I'll be explaining the flex sensors further. Next, for the safety, we have the ultrasonic sensors. Obviously, it will be used for the safety detection. I mean the obstacle detection for the purpose of safety. Next, we have the lights and buzzers. Obviously, if someone who is partially handicapped is driving the wheelchair will be needing the buzzers to inform the others whether the wheelchair is going to go and hit somewhere or like that. So buzzers and lights. So these are for the safety. For the connectivity, we have the Node MCU for the IoT, because it will be IoT enabled. Like people, like we can control it within certain limits. Like uh, someone can control it within certain limits without actually being with the wheelchair. Next, we have the Bluetooth model in case the IoT fails. For like IoT is mainly for the longer distance and Bluetooth is for the shorter distance. Maybe within the home, Bluetooth will work fine. Next, we have two batteries. One is the 12-volt battery and 9-volt battery. One battery will be completely dedicated to work for the microcontroller, to make the microcontroller work, and the other battery will be completely dedicated to drive the motors, which will be helping in the movement of the wheelchair. Next, we have the motor drivers and the DC motors and wires. And for compiling everything, all these with the Arduino Mega, we'll be using the Arduino IDE for compiling like all the hardwares together. The software which we are using is the Arduino IDE. Manuka, next. Okay. So coming to the details of the hardware, this is the microcontroller. Why we are using Mega? Because it is a wheelchair. It will be carrying a person as well as it will be drawing the motor. So we need uh, and also we have certain features, like we have 4 to 5 features which we have to put into a single wheelchair. So a smaller microcontroller would not work fine. So here we have certain specifications of the Arduino Mega board. Next, Manuka. Okay, the gesture sensors. Okay, it is actually going to measure. First of all, we'll be using the accelerometer. So the accelerometer will be will be measuring the speed of the wheelchair. And we'll put a certain limit to the speed with the help of like we'll program it in certain ways. It doesn't exceed the speed, and also the accelerometer will be useful in the detection of the directions. Okay, now communication interface. There are these three various modes of the communication, like the accelerometer meter communicating with the microcontroller. So we have either the analog, the digital, or the PWM, that is the pulse width modulation. So mainly here, like analog, if it is the analog one, it will be using a ADC, analog digital converter, to communicate with the microcontroller. However, if the accelerometer is the digital one, then it will be using either of these two, SPI or I2C. These are the serial communications mainly. These are the serial communication protocols. So both are synchronous serial communication protocols. It will be using either one of them. Otherwise, if the third option is the pulse width modulation, it will be the output will be like the output will be in the form of square wave with certain periods, like, but there will be a like there will be a like in this case, the pulse width modulation, the output will be in the form of square wave. Next, the power of the accelerometer. Okay, why we are actually using accelerometer? It is a low power device, like it will not be using much of the power, since we are already using the motors in the wheelchair. So we need to save power of the battery to draw the motors, and also to carry the weight of the person sitting on it. Manuka, next. gyroscope, this will be actually, this is for the orientation of the wheelchair, so that if there is any abnormality on the road, it doesn't actually fall down. Before falling, it will be like the motors will be, I mean the wheels will be maintaining its balance. So this is also a type of safety measure which will be providing through the gyroscope. It will be responsible for the proper orientation of the wheelchair, so that it can like it can come across if certain abnormality on the road is there, certain obstructions are there, there is an uneven surface, the wheelchair doesn't topple and fall down. So for that we'll be using the gyroscope. Next, Manuka. Also gyroscope will be also helping in the detection of the direction. Next is the flex sensor. Okay, so this flex sensors, mainly we're going to use it for the hand gesture module. So the flex sensor, it is actually that if there is a certain bent on the sensor, there is a certain increase in the resistivity at that certain point of the sensor. Now this increase in the resistance at that point will is marked, like and then that can be used as a signal to do certain things. So mainly like opening your hand and closing your hand, that will be giving different bends to the flex sensors, which will be using which will put together to maintain the hand gesture module of the wheelchair. Manuka, next. Next, we have the ultrasonic sensors. We all know this sensor works on this distance, time, speed formula. So this sensor will be mainly used to detect any unforeseen any unforeseen obstacles which are there. If the person, like if no one is there to control the wheelchair, if the person on sitting on the wheelchair is controlling it, they will be knowing about um, the upcoming obstacles with the help of this ultrasonic sensor. It will be further connected to the buzzers, and also the ultrasonic sensor will also be helpful, like it will be interconnected with the brake system, so that the wheelchair stops in case of any obstacle which is there in front. So from the next slide, Manuka will take over.
Am I audible, ma'am?
Yes, Manuka.
Uh, so for connectivity, we'll be using Node MCU. It is actually a board which is specifically used for IoT based applications. It uses ESP8266 chip. One problem with this board will be that it has got only one analog pin, but there's a like crack for it. There's some IC which is available, which we can connect to this, and that IC will provide us some more analog pins. So otherwise, the board is sufficient for our applications, at least for the initial prototype. One disadvantage was there, which I've told, and it can be overcome with that IC which is available. Uh, so IoT, as we said, IoT will be using for longer ranges and for like operating it over mobile phones. But just in case if like suddenly Wi-Fi goes off and mobile data is also not there, or you're in some remote area, so for a smaller range we'll be giving the facility of Bluetooth also. uh, for this we'll be using HC05 module. Initially, all these are initial modules. As we progress further, we'll be using more industrialized sensors and modules, but initially we'll be using HC05 only for Bluetooth connectivity. For movement, the motor driver that we'll be using will be L293D. All this is again for prototype only. This motor driver will be able to move only small motors. like small DC motors, not the motors which we'll be using in an actual wheelchair. But for our prototype, this motor driver and this motor driver will be enough, and we'll be using four DC motors. Um, yeah, four DC motors. Uh, two of them, two of them's main work will be for turning the chair only, and the other two's main work would be for making it move forward and backward. These are the pictures. The first picture from the left is of the pins of motor driver. The second picture is of the actual motor driver, and the third picture is of the motors, the DC motors that we'll be using for the prototype only. Software details, as we mentioned, we'll be using Arduino IDE for integrating all the sensors and microcontrollers. This IDE uses C# programming. We are quite acquainted with C and C++, and C# is close to them only. So it won't be a very difficult job to code in Arduino IDE. And as we progress, we'll be using different libraries. Initially, we'll be installing the libraries that are required for communication via Node MCU and Bluetooth. As we progress, we'll be installing more libraries that we need. Working head for the head movement, it is simple only. If the head moves forward, both the motors will move forward, so the chair will also move forward, and same for backward. For the left movement, as the head will move towards left, motor 1, which will be the uh, motor towards the left side, and motor 2 will be the motor towards the right side. So if left side motor is moving backward and right side motor is moving forward, so the movement will be towards left. uh, I hope all of you can imagine. Similarly, for right, motor 1 will be forward. Motor 1 means the left side motor, and motor 2, which is the right side motor. So, if the right motor is moving backward and left motor is moving forward, so the turn would be towards the right. So, this will be for head movement control. Similarly, for hand gesture, hands up will go for forward, hands down backward, left for left and right for right. And keeping the hands horizontal will stop the chair, and it will stop all the motors. It will be like brake. Budget, as I told last year, our budget will go to approx INR 6, in between INR 6 to 7K. These prices are from Amazon, so like this is the max budget that we can go. If we go on offline shopping for electronic components, it would anyways be cheaper than this. So this budget is made on the basis of prices available on Amazon.com, and the project was by Aishi, May, and Shansh. Thank you.
So what will be the success rate?
Ma'am, it depends when we'll start the project. We haven't started it till now. So as we start, we'll see where it goes.
Okay, like how much you are expecting? Like कितना success हो सकता है? Because there are so many things. You have to use software also, you have to use hardware also. तो कितना success rate आपको लग रहा है कि आप attain कर पाएंगे एक semester में? So is it possible to complete this project in one semester only?
Yes, ma'am.
So it is possible. So what
Yeah.
are your plans?
Ma'am, we'll be starting it in the next 10 days.
Okay.
The prototype making. Initially, we'll be making a prototype only. All the things that we told in PPT are for prototype. If that goes a success, we'll go for, like, we'll bring a plastic chair and we'll place it on a platform, and we'll connect four wheels to the platform. We'll go to that level. If that also goes success, then we'll start doing things on an actual wheelchair which exists in the market, a simple wheelchair in the hospital, and we'll be inserting motors in it, and we'll be automating it. But initially, it will be a small prototype. Then we'll be using a plastic chair and then the actual wheelchair.
So have you checked these kind of projects on internet? So YouTube, I think already one kind of.
Yes, ma'am. This series, which I told you, it was on YouTube only. Like the people, those who have done it, that's how they did it. They first made a prototype, then they used a plastic chair, and then an actual wheelchair. So people have done it. So we have references from YouTube and other websites.
Okay. So okay. So this is my suggestion. Like try to purchase all the components from local shops. Okay, don't purchase from this Amazon actually, because prices are little higher in Amazon. Okay.
Yes, ma'am.
So if
Yes.
you will visit to some local shop, it will be easier. Then second, I don't think if you are in Karnal and someone, I think Aishi is from Delhi only, and this Shayan, she's also from Delhi. So you can complete.
Ma'am, I am from Kolkata.
Okay, so that is like it is very difficult. Then अभी क्या plan है then? How you are going to complete that?
Ma'am, we are planning to gather
Ma'am,
in
I'll
the
be
next
coming in the next
10
10
days.
days.
But where you are going to stay then, Aishi?
Ma'am, we will be staying like close enough. Like we'll be
Probably,
staying in Delhi most probably. Like
yes,
we
ma'am.
three, we three will be staying in Delhi.
Okay, so okay, then you can start. Okay, so
So our topic is prosthetic devices using IoT, and like our initial, we can say, inspiration was the Jaipur foot, which is like very cheap and affordable, and the ones who started this or like doing it as kind of charity because they were making it really affordable and providing it to those who needed it and could not afford any sort of prosthetic. But the problem is that it was very rigid and immobile, and it can like it did not replace the original limb completely. So innovation was much needed in that case. Like our objective is we will use IoT, 3D printing, and nanosensors to improve the previous models. For 3D printing, the thing is that we have the luxury of customization, which bodes well in each particular case, and we can create a smart lane using desired movement, and it will be made of polymers. We have not finalized which polymer to use, but we have a few options like ABD or bridge nylon, and we are considering using titanium. And the thing is, in this, we will be using much smaller sensors. The previous models had larger sensors. In case of microprocessors, we will be using Arduino Nano and Raspberry Pi 0W. For nanosensors, we will be using nanotechnology, and we will be combining it with IoT. And the thing is, it will make it much more efficient because nanosensors are very sensitive and they are very small in size. For example, if you dissolve a few spoonful of salt in a few Olympic size spoons, it's like that. If you compare, it's very small. And the sensors will be connected to IoT microcontrollers, which will send data through cloud. We can use a custom built app, mobile apps, which can apps also for PCs and such. And there are numerous cloud services we can use. We can use paid services as well for better like security and features. And since data can be sent to and from the microcontroller, we can also get manual control in case in case of an emergency, like if the patient has epilepsy or something and the prosthetic is not in their control. We can use it to like control the situation and something like that. So our goal is to get a durable, good quality prosthetic which are like easily affordable. We plan to make something less expensive than the already advanced models that are out there. And our prosthetic aims to provide relief from phantom pain, and it will also help in their trauma. So these are the references.
Okay, so how much amount you are expecting, like total cost?
Right now our cost is like around 10K, but we are not sure because the thing is we have not finalized which sensors we will be using. We have to do much more research. Like Neha said, we have to do hands-on training to know like what exactly we have to do, and much more. We need much more research for this. We only read a few papers, so we have an idea, but we will be needing more time for this.
So have you searched some kind of institute like where you can complete this kind of project?
The thing is, we were planning to do an internship in IIT, like IIT BHU, but because of COVID, we could not. I think if we had gotten an internship there, like our seniors did, so like we could have done something. But right now, we are looking
But your
where we can do
seniors
this.
didn't go there. They completed their training from this RAI only.
Yes, ma'am. But due to pandemic, like we could not do anything, and right now also, like we are like in different places, so we are looking where we can do and such.
So you all like you are planning to do the same topic for your major one also, like you want to work on prosthesis also?
No, ma'am.
Yes,
Like it's for minor only.
yes, ma'am.
Okay, so you want to work. Okay, so actually I think this is not that much feasible to work because no one from our department have so much idea in the prosthetic devices. So, but
Yes, ma'am.
Yes, ma'am. Like that's why it's becoming like a little bit difficult for us because like we just want to like incorporate with some of institutes so that we can complete this. So like